Sketch the graph of y equals sine of x plus the square root of 3 cosine of x on the interval negative 2 pi to 2 pi. To sketch the graph of the function f of x equals y equals sine of x plus the square root of 3 cosine of x, we would need to gather all the information about the first derivative, the second derivative, as well as the given function f of x. Because of that, we first find the derivative of y equals f of x. F prime of x is derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. This is cosine of x minus the square root of 3 times sine of x, and we find critical numbers. To find critical numbers, we set this first derivative equal to 0 and we solve for x. Isolating cosine of x, we have cosine of x equal to the square root of 3 sine of x. And then we divide by both sides by sine of x, assuming that it is not 0. This is cotangent of x equals the square root of 3, or tangent of x equals 1 over the square root of 3. The trick to find tangent is to divide it by 1 over root 3 by 2 in the numerator and the denominator, and we see that for tangent of x to be 1 over root 3, the y-coordinate on the unit circle is 1/2, and the x-coordinate on the unit circle is root 3 over 2. And that happens when x, or the angle, is pi over 6. The terminal point determined by the angle pi over 6 is x equals the square root of 3 over 2 and y is 1/2. But tangent is also the same in the third quadrant as well, when x is negative root 3 over 2 and y is negative 1/2. So tangent is also positive in the third quadrant. And we see that by symmetry, if this angle is pi over 6, then the angle in the third quadrant is 7 pi over 6. So we conclude that tangent of x equals 1 over root 3, or the derivative is 0 when x equals pi over 6, 7 pi over 6. And because this is on the interval negative 2 pi to 2 pi, we need to go back 2 pi length. The answer pi over 6 and 7 pi over 6 is in the unit circle from 0 to 2 pi. To obtain the zeros of the derivative from negative 2 pi to 0, we would go back. From pi over 6, we would go back 2 pi, subtract 2 pi from pi over 6 to get negative 11 pi over 6. Similarly, from 7 pi over 6, we subtract 2 pi. 7 pi over 6 plus 12 pi over 6 is negative 5 pi over 6. And so we obtain all 4 critical points. It is tricky with trigonometric functions because trigonometric functions are periodic, and tangent of x is no exception. We found the two solutions in the interval 0 to 2 pi, but the critical points by definition are all of the x values such that the first derivative is 0 in the domain. If we were to plug negative 11 pi over 6 into f prime of x, we will see that it is 0. So it's negative 5 pi over 6. So now we found all 4 critical numbers in the given domain. We can construct the sign chart for f prime. But before we do that, we should go ahead and find the second derivative because we want to have the sign chart for both f prime and f double prime. Since f prime is cosine of x minus the square root of 3 sine x, f double prime of x is negative sine x minus root 3 cosine of x, where the derivative of cosine of x is negative sine of x, and the derivative of sine of x is cosine of x. We then set the second derivative equal to 0 and find the cut points. These are no longer the critical points. We isolate sine of x by move negative sine of x to the left-hand side to get sine of x equals negative root 3 cosine of x. And then we divide it by both sides by cosine of x, assuming that cosine of x is not 0. Then we have tangent of x equals negative the square root of 3. And again, this is negative the square root of 3 over 1. In order to use the unit circle to solve it, we divide it by the top and the bottom by root 2. By the definition of tangent of an angle, it is the second coordinate on the unit circle over the first coordinate. For tangent to be negative, the angle has to be in the second or the fourth quadrant, because in the second and the fourth quadrant, the sign of x and y coordinates are opposite. For the x coordinate to be 1/2 and the y coordinate to be negative root 3 over 2, the angle had to be in the fourth quadrant. Or for the x coordinate to be negative 1/2, the y coordinate is positive the square root of 3 over 2. And the two occurred when x is 2 pi over 3 or 5 pi over 3. But these are angles in the interval from 0 to 2 pi. We need to find all zeros of the second derivative in the interval negative 2 pi to 2 pi. To do that, since this is a trigonometric function, we simply subtract 2 pi from each of these numbers. 2 pi over 3 minus 2 pi is the same as 2 pi over 3 minus 6 pi over 3, which is negative 4 pi over 3. Similarly, 5 pi over 3 minus 6 pi over 3 is negative pi over 3. And we found all four zeros of the second derivative in the interval negative 2 pi to 2 pi. Now that we have the zeros of the first and the second derivative, and also the first and the second derivative and the given function are defined everywhere, we know for sure that we obtain all cut points of the first and the second derivative. For the sign chart of f prime and f double prime, we only need to construct the sign chart in the interval negative 2 pi to 2 pi only, because this is the given restricted domain. For f prime, the critical numbers or the cut points are negative 11 pi over 6, negative 5 pi over 6, pi over 6, and 7 pi over 6. There are four cut points that cut the interval negative 2 pi to 2 pi into 1, 2, 3, 4, 5 subintervals. We then test the sign of the first derivative in each of these subintervals. For the first interval from negative 2 pi to negative 11 pi over 6, we plug in any number in this interval, such as negative 11.5 pi over 6, but any number will do. Plug in negative 11.5 pi over 6 into the first derivative, we see that the sign of the first derivative is positive in this interval. Plug in a number between negative 11 pi over 6 and negative 5 pi over 6, such as negative 6 pi over 6, negative 7 pi over 6, into the first derivative, would give us a negative sign for the first derivative. And then we keep doing it for each of the subinterval. For negative 5 pi over 6 to pi over 6, we might as well pick 0. Again, any number between the endpoints in each of the subintervals. If we plug 0 into the first derivative, we have cosine of 0 is 1 and sine of 0 is 0. 1 minus 0 is positive. And again, we keep doing this for each of the subinterval. We then construct the sign chart for the second derivative in the interval negative 2 pi to 2 pi. The cut points of the second derivatives are negative 4 pi over 3, negative pi over 3, 2 pi over 3, and 5 pi over 3. We then plug any number between negative 2 pi to negative 4 pi over 3 into the second derivative. For instance, if we plug in negative 5 pi over 3 or any number into the second derivative, we will see the negative sign of negative 5 pi over 3 minus 3 times cosine of negative 5 pi over 3 will be negative. Then we pick a number in the next interval and we will see that the second derivative is positive. Any number between negative pi over 3 to 2 pi over 3, for instance 0, negative sign of 0 is 0 minus root 3 times cosine of 0, which is negative root 3 times 1. So it is 0 minus root 3, which is negative, and then positive, and then negative. Don't assume that the sign alternate. Make sure you evaluate the number in each of the subintervals. We now combine both sign charts to determine the shape of the graph of the function f. We stop at each of the cut points. First cut point is negative 11 pi over 6. The next one is negative 4 pi over 3. Again, from both sign charts. The next cut point is negative 5 pi over 6, negative pi over 3, pi over 6, 2 pi over 3, 7 pi over 6, and 5 pi over 3. Don't forget the endpoints. From negative 2 pi to negative 11 pi over 6, the first derivative is positive, so the function is increasing. The second derivative is negative, so the graph is concave down, increasing and concave down. From negative 11 pi over 6 to negative 4 pi over 3, the function is decreasing because f prime is negative, and concave down because the second derivative is negative, decreasing and concave down. From negative 4 pi over 3 to negative 5 pi over 6, the derivative is negative, so the function is decreasing, but the second derivative is positive, so the graph is concave up, decreasing, and concave up. From negative 5 pi over 6 to negative pi over 3, the first derivative is now positive, which means the graph of the function f is increasing, and the second derivative is also positive, so the graph is increasing and concave up. From negative pi over 3 to pi over 6, the function is increasing and is concave down. From pi over 6 to 2 pi over 3, f prime is negative, so the function is decreasing, and f double prime is still negative, so the graph is concave down. From 2 pi over 3 to 7 pi over 6, f prime is negative and f double prime is positive, so it is decreasing, concave up. And from 7 pi over 6 to 5 pi over 3, f prime is positive and f double prime is also positive, increasing and concave up. From 5 pi over 3 to 2 pi. F prime is positive, increasing. F double prime is negative, concave down. We then put these all together in the graph. There are features of the graph that we can obtain from the first and the second derivative, specifically the sign charge of the first and the second derivative, and that is the maximum, the minimum, and the inflection point. F prime changes the sign at negative 11 pi over 6 from positive to negative, so the function f has a local maximum at this point. F prime changes its sign from negative to positive at negative 5 pi over 6, so the function f attains its local minimum, and so on. To sketch the graph, we also see that since the second derivative, f double prime, has exactly the same terms, sine x and root 3 cosine of x, the only difference is that f double prime is the negative of the given function, so the zeros of f double primes are also the zeros of the given function, and these zeros are 2 pi over 3, 5 pi over 3, negative 4 pi over 3, and negative pi over 3. So we know that the graph will crosses the x-axis at these points. These are the x-intercept. Also, if we plug 0 into the given function, we have sine of 0 is 0 and cosine of 0 is 1. Root 3 times 1 is the square root of 3, or roughly 1.7. So we also obtain the y-intercept as well. Also, if we plugged negative 11 pi over 6 into the given function, we have sine of negative 11 pi over 6 plus the square root of 3 times cosine of negative 11 pi over 6. Sine of negative 11 pi over 6 is 1/2. Cosine of negative 11 pi over 6 is root 3 over 2. So this is 1/2 plus 3 over 2, or 4/2, or 2. At negative 11 pi over 6, we have a local maximum at y equals 2. This is periodic, so we will see that the local maximum at pi over 6 is also 2. The local minimum at negative 5 pi over 6 is therefore negative 2. The local minimum at 7 pi over 6 is therefore also negative 2. These are the points that the graph of f has to go through. On the interval negative 2 pi to negative 11 pi over 6, the function is increasing and concave down. From negative 11 pi over 6 to negative 4 pi over 3, the function is decreasing and concave down, and it has to go through the x-intercept. From negative 4 pi over 3 to negative 5 pi over 6, the function is decreasing and concave up, and it has to go through the minimum. From negative 5 pi over 6 to negative pi over 3, the function is increasing and concave up, and it has to go through the x-intercept. From negative pi over 3 to pi over 6, the function is increasing and concave down, and has to go through the y-intercept and the maximum. From pi over 6 to 2 pi over 3, decreasing and concave down. From 2 pi over 3 to 7 pi over 6, decreasing and concave up. From 7 pi over 6 to 5 pi over 3, increasing and concave up. And from 5 pi over 3 to 2 pi, increasing and concave down. If we were careful with the coordinate, the distance between the numbers, then we would obtain a more accurate graph for the function f, but this is the sketch of the graph of f. Since this is a periodic or trigonometric sine and cosine, the local maximum are also absolute maximum, and the local minimum are also absolute minimum.